In this video, we want to take a deeper look at workers. Unlike the previous videos, we will be using Plant Simulation version 2404. This version comes with some settings that were not available in version 2302. Particularly, great features for the worker were implemented that we want to showcase in this video. If you are not familiar with the worker, we highly recommend watching videos 16 and 17. The first concept we want to introduce is the home location. This is a new feature enabling us to let the worker wait at a certain place after completing the job. In the previous version, the worker would either stay at the workplace or walk back to the worker pool. Now, we are able to define a workplace at which the worker should wait. Additionally, the worker will be immediately beamed to his workplace at the start of the simulation. To showcase this, we have inserted a worker pool, a broker, a station, a drain, and a source. We will now insert two workplaces, one at the station, where we activate the processing importer, and one next to the station. The second workplace will serve as our home location where the worker will stay until he is requested by the station. Then we open the workplace at the station. Here, we naturally uncheck the last checkbox as we do not want the worker to stay at the station after completing the job. If we would start the simulation now, the worker would return to the worker pool after completing the job. However, we now open the dialog of the worker pool. Then we click on Workers to create. This field was named Creation Table in the previous version. Additionally, we do not need to deactivate the Inheritance checkbox in the current version, other than the previous one. In the upcoming dialog, we can now see a column named Home Location. In this column, we can enter a home location for the worker, at which he should stay after completing the job. Additionally, the worker will be beamed to this home location at the start of the simulation, and no longer start his job from the worker pool. Now, we can simply drag and drop the workplace into the column and click on OK. We then introduce an interval at the source to be able to see that the worker walks to the home location after processing the part. Therefore, we set the interval to 30 seconds. After we have done this adjustments, we can start the simulation. As you can see, the worker will stay at the home location after completing the job. We will now introduce the concept of the checkbox Choose the nearest worker at the broker. To set up our model for that, we place a third workplace next to the station. This workplace is obviously closer to the station than the other workplace. We then open the Workers to create table and create a second worker. We then assign the third workplace to the worker as its home location. We then start the simulation. Now, intuitively, we would think that worker 2, which is also immediately beamed to the third workplace, is assigned the processing task at the station. However, as this worker is in the second row of the Workers to Create list, it won't be assigned. The broker will assign the processing job to the first entry of the list. If you want to change this, we can now make use of the Choose Nearest Worker checkbox. To do so, we open the broker and check this checkbox. Now, the broker will assign the job to the nearest worker. If we start the simulation now, we will see that the worker on Workplace 2 will be assigned to the job. Now, we will introduce the scope of a worker. First, we move the second workplace in front of the first station. Then we copy and paste the source, the station, the drain, and the workplace 4 times. Then we will set the processing time of 2 stations to 25 seconds. The scope of a worker can be defined at the Workers to Create list. So we open it. Here, we can now see a column for the scope. In the scope, we can enter an object where an importer is activated. A worker which has a scope that matches a request is mediated before a worker without a scope. We will now enter station and station 1 as the scope of the first worker. For the second worker, we will enter station 2 and station 3 as the scope. To visually distinguish the workers, we will change their appearances. However, instead of duplicating the worker, we should derive it. The reason for this is that the workers use poses when walking. These poses are saved as graphics which require lots of memory and space in the model. So, instead of duplicating the worker, we derive it. Then, we open its 3D properties and change to the Appearance tab. Here, we then change the diffuse color. Then, we drag and drop this worker in the second row. We have now established 2 workers to operate at the stations within their respective scopes. We will now introduce a third worker, who can be regarded as a so-called jumper. With 2 stations assigned to each worker, bottlenecks may arise where the jumper will provide assistance. So the jumper will perform the tasks of a worker unable to process a part at one station within their scope. To introduce the jumper, we create a third worker. We are now ready to start the simulation. We will now see 3 workers. The worker in the default appearance has the first and the second station as his scope, whereas the worker with the green appearance has the third and fourth station as his scope. The jumper has a red appearance and has no scope defined. Now 2 behaviors become apparent. Firstly, as the scope is hierarchically more important than the nearest worker, the first worker will be assigned to the job at the first station by the broker, even though the second worker is closer to it and the checkbox, "Choose the nearest worker," is activated. Secondly, the first worker will only work at stations 1 and 2, whereas the second worker will work at the 2 other stations. The jumper will help out depending on the needs and will return to the worker pool if there is no need for assistance. Now we will show another feature, which is called Worker Queue and Barred Areas. To do so, we switch to a new model frame. In this model setup, we have inserted a worker pool, a broker, 4 workplaces, and connected the sources to the station to specify the destination for the parts. We have activated the transport importer at the sources. For the workplace at the station, we have deactivated the option for the worker to stay at the workplace after finishing the job. We have additionally adjusted the start and interval times of the sources. This is done to enable the sources to request different workers from the worker pool. In version 2404, by default, under the user objects, we have 2 different parts with different appearances that we have used in the sources. We now want to model a queue as in the airport at the security checks. This is something we have modeled using fences. Here, we have basically inserted multiple fences and then grouped them, which you can see in the graphic structure dialog. In the following, we will demonstrate how to define the queue in the simulation. But first, we start the simulation without any adjustments. You will see that when the workers leave the worker pool, they follow the shortest route to the sources, entering through the first access point. Once they've delivered the parts to the station, they once again opt for the shortest path to the sources, leading them to use the second entry. So there isn't a designated entry point for the workers to access the sources. Additionally, the workers do not consider the graphics of the fence when they line up one behind the other. We now aim to modify these two behaviors and implement a more structured approach. To do so, we introduce barred areas. These areas can be used to specify where a worker should be able to go. We first switch to the Edit ribbon and then click on Barred Area. Now we will use a specific form of barred areas called one-sided delimitation. These can be used to make the worker able to cross the dashed side, but not the solid side. We now want the worker to move to the source from the second entry and leave from the first. To achieve this, we place the barred area accordingly. We then can simply copy and paste the area to place a second one. We then repeat this process for the other sources. We can then start the simulation. You will now see that the workers only walk through the second entry and leave through the first one. Now we will come to the second feature, which is the worker queue. As the name indicates, we can define a worker queue at which the workers wait. To do so, we open the 3D dialog of the workplace at the station. Then we switch to the MU Animation tab and click on Animation Path. Here an animation path will be shown by default. However, we want to show you how you can create an animation path from scratch. So we delete this animation path. Now we need to create a new animation path. So we click on Add. Now it is crucial to not just use a random name for the predefined path names. We click on the 3 dots. Now we can see which names we should use. As we intend to implement a queue, we opt for the second one. Then we select Spline as the type. Now we click on Show. As we can see, the cone is at the workplace. We first take the cone and move it to the beginning of the fence. Then we can click on Extend and create a path. After creating the path, we can close the dialogues. Now we open the dialog of the workplace. Here, we then activate both checkboxes, the first one to let the workers move to the end of the animation path of the queue, the second one to let them walk along the animation path. Let's start the simulation now. At the beginning, there will be workers which go to the workplace even when there is another worker and jump back to the queue. The reason for this is that when the worker calculates where to walk and wait, it can't take into account that there might be another worker which has calculated a route to the same position. We could technically implement this, however. This would come with high demand for computing resources, resulting in poor performance. Additionally, you might want to change the distance between the workers in the queue. To change this, we can open the dialog of the workplace and adjust the distance in the queue. With this, our video on workers is concluded.